Hey guys, welcome to CPM 2. This is Module 1, Lesson 3 over Section 2.1, Intro to Integers. So Objective A is to represent real-life situations with integers. This paragraph right here says, so far all numbers have been 0 or greater than 0. Numbers greater than 0 are usually called positive numbers. However, sometimes situations, this is supposed to be exist, that's a typo. However, sometimes situations exist that cannot be represented by a number greater than 0. So, to represent these situations, we need numbers less than 0. Extending the number line to the left of 0 allows us to picture negative numbers, which are numbers less than 0. So, you can see right here on this number line, up until this point, we've only been kind of dealing with this side right here. All of our answers have always been positive and nothing else. So now, after you have 0 here, now it goes -1, -2, -3, and as it keeps going here to the left, these numbers keep getting smaller and smaller and smaller, even though these numbers are going up technically, right? You've got 1, 2, 3, 4, 5, but think of this in terms of money. If you owe somebody $1, that is a bigger number than owing somebody $5. So as it goes this way to the left, those numbers are getting smaller. And so you have a little helpful hint here that does say, notice that 0 is neither positive nor negative. So notice here, there's not a positive in front of it or anything like that. You've got positive numbers here. You've got negative numbers here. 0 is neutral. It's not positive nor negative. So when a positive sign, or this is a big one, no sign is in front of a number, the number is positive. When a negative sign is in front of a number, the number is, of course, negative. The big one on this is that positive, when you see the no sign, that's known to be positive. So if you look here at this number line, it doesn't say +1, +2, +3, +4, +5. You've got no sign in front of it, so it's known to be positive. Okay, so this is just a little helpful hint. You guys can read that on your own. Let's go to example 1. Example 1 says represent the given situations with an integer. So we can see here we are below that 0 mark. We are 5 degrees below 0. So that just simply means to represent that is -5 degrees. Usually you want to put degrees Fahrenheit, degrees Celsius, but since we don't know what unit we're in, we'll just put the little degrees sign. And then on situation B, you have the sea level, so think of that as your 0. And now we are 20 feet below, so that is a -20 feet. You do need those units there. Units are very important. Okay, let's turn that page. So objective B, we are graphing the integers on a number line. So notice here, we only have 3 numbers on these number lines. We've got a -10, we've got a 0, and we've got a +10. So to graph -4, we've got -1, we've got -2 here, -3, and so right here is my -4. We need to graph -1. We already have labeled -1. We need a +2. So from 0, we go over 1, then 2. So here's my 2. And then we also need to graph a -2. So those are my 4 points for those 4 numbers. Example 3 is the same thing. We need to graph 7. So we've got 1, 2, 3, 4, 5, 6, 7. -6, so -1, -2, -3, -4, -5, then there is my -6. These other ones are nice and easy since we already have them labeled. We need a -1, a -3, and a +3. So those are my 5 points on that one. Objective C, compare integers. We compare integers by using a number line. For any two numbers graphed on the number line, the number to the right is the greater number. The number to the left is the smaller number. Also, symbols like, this is your less than. Oh, we're about to do that. Okay, symbols like this and this, these are called inequality symbols. So, what do these inequality symbols mean? When it is pointing towards all of those positive numbers, if you kind of look at this and use it as an arrow, it is pointing to the right. When it points to the right, that's all the positive numbers, right? You've got all the positive numbers on this side. So this is your greater than symbol. And then you use this symbol here. It looks like it's pointing to the left. To the left is all of your negative numbers. So this is your less than symbol. I also remember this less than symbol because it's almost like if you turn your paper sideways, it makes like a little bit of an L. So that's how I remember that that's a less than symbol because it kind of makes an L. Again, I can't really do it on this video, but if you turn your paper just a little bit, it makes an L. So insert your less than and greater than symbol between each pair to make a true statement. I've always been taught to kind of treat these guys as like a Pac-Man, and your Pac-Man wants to eat, if you would, the bigger number. Okay, so in A, we've got -7, we've got +7. Well, which one is a bigger number? That's going to be your +7. So we're going to eat the bigger number. And so then this reads, -7 is less than 7, which that's a true statement. Over here, these negatives will get a little tricky sometimes. You've got 0 and you've got -4. So a lot of times we think, well, 4 is bigger than 0, and that would be true. But when you're dealing with negatives, think almost as money. Is it better to have $0 or is it better to owe somebody $4? Okay, so your bigger number here is that 0. So now this one reads 0 is greater than -4. Now, when you have two different negatives, it's very tempting to say that this -11 is bigger because 11 is a bigger number. But when it comes to negatives, you almost got to think opposite. When you're looking at that number line, right, you've got 0 down here. You've got all of these negative numbers here in the middle. Then we've got -9. We've got -10. We've got -11. Remember, the further we go to the left, the smaller those numbers are getting. So actually, -9 is the bigger number in this problem. So we're going to eat that -9. And again, thinking money, right? Would you rather owe somebody $9 or would you rather owe somebody $11? Okay, same thing on D. You've got -15 and -10. It's so easy to say this -15 is bigger, so we're going to make that Pac-Man eat that -15. Thinking money. Would you rather owe somebody $15 or owe somebody 10? I'd rather owe somebody 10. That's a less amount, so it makes it greater. Objective D, find the absolute value of a number. The absolute value of a number is the number's distance from 0. And because we're talking, okay, I'll keep reading this, sorry. The absolute value of a number is the number's distance from 0 on a number line. The symbol of the absolute value is these little double bar looking lines. For example, this little double bar with a 3 in the middle is read as the absolute value of 3. This helpful hint here is what I was about to say before I stopped myself and kept reading. Because we are talking about distance, it doesn't matter if you walk forward 5 steps or if you walk backwards 5 steps. You are still traveling the same amount of distance. And because of that, when we're talking about these absolute values, it is never negative. Okay, these will always, always, always be positive. So, simplify. We've got the absolute value of -9. The absolute value of -9 is a positive 9. The distance from 0 is still 9 units, even though it's going in the negative direction. Since it's distance, it's still 9 units away from 0. The absolute value of 8 is positive 8. So you can see here, it does not matter if we have a negative in those absolute value brackets or a positive. The outcome is always going to be a positive number every single time. The absolute value of 0, well, we have that right here, is 0. Absolute value of -6 is positive 6. And absolute value of 4 is 4. Always positive, no matter if it's negative or positive inside those brackets. Objective E, find the opposite of a number. So, it says here, 2 numbers that are the same distance from 0 on a number line, but on opposite sides of 0 are called opposites. So it has, for example, 4 and -4 are opposites. You've got -4 is 4 units away. You've got +4 is also 4 units away. So we'll learn later that those kind of cancel out, but those are considered opposites. So example 6, find the opposite of each number. So the opposite of a positive 13, remember if you see no sign in front, that is known to be a positive 13. So the opposite of a positive 13 would be a negative 13. Opposite of a -2 would then be a positive 2. Opposite of 0, remember 0 is that only one here that's neutral. It's not positive, it's not negative. So the opposite of 0 is 0. It's the only one that will repeat itself. The opposite of 14 is -14. And the opposite of -9 is a positive 9. Okay, let's kind of put those last two together a little bit. Okay, we write the opposite of as a negative. Therefore, to find the opposite of a number, we replace the negative sign in front of the number. Therefore, to find the opposite of a number, we place a negative sign in front of the number. So, I'm not going to write this for all of them. But this little negative out in the very front means the opposite, I'm just going to put oppo, the oppo of -4. Well, what is the opposite of a -4? That is +4. And we'll kind of come to realize when you have a double negative here, that just kind of turns into a giant plus sign here. This one here means, this right here means the opposite of the absolute value of -5. Okay, well, what is the absolute value of -5? The absolute value of -5 is a +5. So what's the opposite of this +5 then? That is -5. Okay, another way to think of that, and I'll do that in a space down here, so I'm going to have to erase it later. When you've got negative absolute value of 5, it's almost like you're not even paying attention to this negative at first, okay? The absolute value, I'll change colors again. The absolute value of -5 is 5. And then you got to take this negative that's on the outside and carry it down. Okay, that's another way to think of that. It's probably actually, and honestly, an easier way to think of that. Okay. So let's think of C in the way that we just did that last one. Instead of saying which this is what that means, right? The opposite of the absolute value of 6. The absolute value of 6 is 6. And then you got to take this negative that's on the outside and carry it down. So this is -6. Okay, on D, you can either say the opposite of -12. So what's the opposite of -12? Or remember this same rule here that double negative, you can change that into just a giant plus sign. And so this becomes 12. Okay, and then on E, the absolute value of 25 is 25. And then you got to take that negative that's on the outside and carry it down. All right, example 8. Evaluate the opposite of the absolute value of -x if x equals 2. So let's remember back to last lesson. The best way to do this is take wherever you see that variable and place it with some parentheses. So that means I have the negative absolute value of a negative something and close those absolute value signs. Well, I know that x equals 2. So I'm going to put a 2 in where I see that x. So now evaluate. So the absolute value of a -2 is a +2, but then that negative on the outside needs to come down, and so this becomes a -2. Okay, and then I believe very close to the last thing, you'll have a couple of problems like this in your homework. Okay, let's try and get rid of that line. I guess I can't. Okay, write the given numbers in order from least to greatest. Notice it says right here, do not perform calculations. So we have to perform calculations to figure out what number is bigger than the other number. But then when you put your answers on these lines, it needs to be in this form here, not what they simplify to be. So let's just take the very first one. We've got -3. So either read this as the opposite of -3, which the opposite of -3 is 3, or change that double negative into a huge plus, and that becomes +3. So either way you think of that. Next, we have the absolute value of -8. Well, the absolute value is just the distance from 0. Distance is always positive, so the absolute value of -8 is +8. We have -9. -9 can't simplify to anything, so -9 is -9. We have a 4 squared. 4 squared means 4 times 4. 4 times 4 is 16. And then lastly, we have the negative absolute value of -6. So the absolute value of -6 is +6, but then take that negative, carry it down, so we get -6. Okay, so these are my my 5 numbers and what they simplify to. So now put them in from least to greatest, but it needs to be in their original form. So my least number, my smallest number here is going to be -9. Okay, think of that number line. You've got -9 way over here from that 0. So we're going to put -9 first. My next number is the only other negative number we have, which is this -6. So -6 is going to be somewhere over here. But this is what it means by do not perform the calculations. It doesn't want -6 as the answer. It wants the negative absolute value of -6. So now these last 3 numbers are positive numbers, and we're pretty good with positive numbers. We've got this one to be third, then this one would be the 4th one, and then this one would last be the greatest number. So my third number of 3 here was that -3. This one here was the absolute value of -8, and then my last one would be that 4 squared. Okay, so that's what it's looking for. And then lastly on this page here, we need to be able to read a bar graph containing integers. It says here that the bar graph below states the average daytime surface temperatures of the 8 planets, excluding the newly classified dwarf planet, Pluto. That's supposed to be a comma there. Notice that a negative temperature is illustrated by a bar above the horizontal line. So these here would all be positive. Oh, I'm sorry, below. So my negative ones here, that's what it's talking about. The negative temperatures are below your 0. So then what I circled before, your positive temperatures are illustrated by what's above that horizontal line. So example 10. Use the bar graph above to answer the following questions. Which planet has the lowest average daytime surface temperature? Okay, so because it's the lowest one, I want the one that is the lowest number down here, the one that's the furthest from that 0. So that's going to be this guy here. It's almost Uranus, but by 7 degrees, it is going to be Neptune. And then which planet has the highest average daytime temperature? So now I want to see which one is the highest, which one is the furthest from that 0. And again, that's actually a close one. It's going to be Venus right here, that this number is bigger than this one here. So then we've got Venus. All right, that's all I got for lesson 3 in module 1. Please rewind this video as you see needed.